So you could unmute yourself or write in the chat. I prefer you to unmute yourself, though, if you do have a question. All right, any questions on number 1, 460? Okay. Any questions on number 2, negative 80? Number 3 is negative 3. Number 4, ignore the work on here. You could just plug that right in your calculator. Number 5, the words inclusive here mean that 4 and 44 were going to be included in your answer. So I'm not sure if you knew what that word meant in regards to numbers, but you were including 4 and 44 when you were finding the number of terms there. And the last one that you had to do was number 6, 108. Okay. All right, if we have no questions on those, we are going to go into the notes for today. So the notes for today are actually pretty similar to the notes from yesterday in regards to being series. Today, though, it's all going to be about geometric series. Okay. So on the top of our paper, and the formula that we're going to have to reference today is going to be our geometric sequence formula. All right. So I'll write it on the top of the paper here. So the geometric sequence formula is AN equals A1 times R to the n minus 1. All right. So remember, A1 is your first term. These geometric sequences go up by a common ratio, so something that we're going to be multiplying by. N is going to be your term number, and AN is going to be your term value, just like it was before. Okay. So in the do now, it says find the number of terms. So if I'm trying to find the number of terms, I am trying to solve for n. I don't know how many terms there are going to be in this sequence. Okay. So when I look at this sequence, who can tell me what the common ratio is? How am I getting from 4 to 12, 12 to 36?
Timesing by 3.
Good. Thank you. Times by 3, times by 3. Okay. All right, so we know that A1 is equal to 4. We know that R is equal to 3. And we don't know how many terms, but we know that last term value. So we know A of n is equal to 972. Okay. Let's just figure out what spot in line or what term number 972 is. So let's plug in those values that we have. 972 equals 4 times 3 to the n minus 1. Okay. And our first step here to solve for n is going to be to divide by 4. So 972 divided by 4 is 243 equals 3 to the n minus 1. Okay. Two different ways how to solve this, because you can do common bases because this is going to be a common ratio of 3. So you know that the base is going to be 3. The other way that we're very familiar with is if our variable is in the exponent, we're going to write this in log form and then just use our calculator to calculate. So if we were to write this in log form, we would have log base 3 equals n minus 1. So in your calculator, I'll bring my calculator over here. You're going to go, remember, to alpha window, number 5, log base 3 of 243. Click enter. You'll get 5. Okay. So I'll just, I'll bring it over here, I guess. 5 equals n minus 1. And then you add 1 to the left-hand side to find out that n is equal to 6. So there are 6 terms. Okay. Does anybody have any question on that? So it's a lot of just like finding what information they give us and then finding what we need in order to either compute the sequence or the series that we're going to do. So just like yesterday, when you added up the terms of the arithmetic sequence, you got an arithmetic series. If we add up the terms of a geometric sequence, we're going to get a geometric series. Okay. So exercise 1 says, given a geometric series defined by the recursive formula, okay, we know recursive formula, we're going to be using the previous term. So A1 is equal to 3, great, the first term's 3. AN is equal to the previous term times 2. Times 2. Okay, so if we were talking in geometric terms, this would really be our ratio, what you would be multiplying by, that times 2. Which of the following is the value of the big S you learned yesterday means sum? Okay, we also learned that this big sigma also means sum. Okay, so we're trying to find the sum of from term 1 to term 5. Okay. So they gave us the first term. A1 is equal to 3. In order to find A2, using that recursive formula, previous number is 3 times 2. And you get 6. To find the third, 6 times 2, you get 12. To find the fourth, 12 times 2, you get 24. And then to find the fifth, you get 24 times 2, which is 48. Okay. We're not done though because we need the sum. So we need to add up all of those numbers. So let's add in our calculators 3 plus 6 plus 12 plus 24 plus 48. And then we'll get our answer. So 3 plus 6 plus 12 plus 24 plus 48. And you should get 93. I hope that in class right now you are participating and putting it in your calculator as well. We have a test on Friday and this stuff is all on it. So if you have a question, don't be shy, unmute yourself and ask. All right, so here is the formula for our geometric series. It's written 2 different ways. This is the more common way, and if you do have a Regents, this is the way that it is shown on your reference sheet. Okay, so like we do with all the other formulas that I give you, I like to write out what each variable represents. And by now, you might know what all these represent when you look at it, but it's nice to see it on paper. So S of n means sum. Okay. A1 is equal to first term. R is our ratio. And n is our number of terms. So just like yesterday, when you're trying to find this geometric series, you're going to look and see if the problem gives you all of those values. And if it doesn't, then you have to use the sequence formula to find one of those values. Okay. So let's see what exercise 2 gives us. Which of the following represents the sum of a geometric series with 8 terms whose first term is 3 and whose common ratio is 4? All right, so I look at my formula here. I know in order to use it, I need A1, I need R, and I need N. I'm going to see what they give us. So 8 terms, that's your N. The first term is 3, so A1 is 3. And the common ratio is 4, so R is 4. Okay, start off nice and light, give you all of them. All right, so let's plug that into our formula. So S and N is going to be 8. So the sum of the first 8 terms, 3 minus 3 times 4 raised to the 8th over 1 minus 4. Okay. And then, like I always say, no funny business when you're playing with your calculator and putting these functions in. You're putting it in exactly how you see it. These calculators are meant to handle these high-level math questions. So you're going to go to alpha y equals, click enter, and then plug in exactly what you see. So 3 minus 3, parenthesis 4. Oh, I should put a parenthesis 4, exponent 8 over 1 minus 4. Click enter, and you should get 65,535. Which is choice number 4.
Miss Gutter?
Yeah.
Do we have to memorize all the formulas?
You don't have to memorize a single formula. You just have to know how to use it. They're all going to be given to you. You just have to know how to use it.
Okay, thank you.
You're welcome. Okay, find the value of the geometric series shown below. Show calculations that lead to your final answer. So the word series, you would know that you're using this formula that we just learned about. Again, you need to know what A1 is. You need to know what R is and what N is. All right, great. We know A1 is 6. Who can tell me what R is? How do I get from 6 to 12? 12 to 24.
Multiply by 2.
R is 2. Do I know how many terms there are? No, right? I have no idea how many terms there's going to be, but I do know the final spot. So I don't know what N is. So if I don't know one of those variables, I have to use the geometric sequence formula. All right. So again, this is going to be given to you. A(n) equals A1 times R to the n minus 1. Okay. So we're trying to figure out what term number 768 is. So that's our value. 768 is equal to A1 is 6, R is 2 to the n minus 1. And just like we did in the do now, we're going to divide first. So let's divide 768 by 6. Get 128. Okay. And then when we're at this point here, our variable is our exponent. So we're going to put this into log form. So log, the base is 2 of 128 equals n minus 1. Calculator, alpha window, number 5, 2, and 128. enter. You get 7. So 7 equals n minus 1. When you add 1 to the other side, you will get n is equal to 8. So we found out n is equal to 8. Now I want you to plug this into our series formula and find the value. Okay, so you can look right above. Okay, once you plug in those values, I want you to use your calculator, find the actual sum. All right, did we get 1,530? I can't really see you, but if you did, good. If not, speak up and I will address any questions. Oh, this is such a fun problem here. All right. So a person places a penny in a piggy bank on the first day. So 1 penny on the first day of the month. 2 pennies on the second day of the month. 4 pennies on the third day, and so on. Something you think that maybe you can do. You could put a penny in a piggy bank, and then 2 pennies in a piggy bank, 4, etc., then 8, and so on and so forth. Will this person be a millionaire at the end of 31 days? Okay, so if you did that, think in your mind right now whether you think you would be a millionaire if you continued this pattern on for 31 days. Okay? And then maybe try it at home and see how it goes for you. But let's see how we do here. So again, our formulas, because you just flip the page over, you have Sn equals A1 minus A1 r to the n over 1 minus r. And if we are missing a piece of information, we're going to use An equals A1 times r to the n minus 1. All right. So on day 1, it was 1 penny. So A1 is equal to 0.01. That's how you represent a penny. On the second day, it was 2 pennies. So if my pattern is 0.01 and then 0.02, and then the third day was 0.04, in order to find our R, you're going to do 0.02 divided by 0.01, and you'll get 2. And the number of terms. We know how many terms. We know how many days. They told us right here, 31 days. Okay, let's plug that information in and see if we're going to be millionaires. So the sum of the 31 days A1 minus A1 times R to the 31st over 1 minus 2. Alpha y equals, enter. Okay, click enter. And look how much money you'd have at the end of the month if you continued that pattern. All right. You would have a total of $21,474,836.47. Okay. It's pretty incredible. Maybe some of you who have jobs are thinking, okay, what would happen? Or you might even do this math already. What would happen if I put $5 away in a jar each month? Or some of you, when you get your paycheck, maybe you put a certain amount of your paycheck away each month or each week whenever you get paid. And at the end, it all adds up. Okay, whether you increase or decrease how much you contribute to it, it'll all add up at the end. And you might have a nice payday when you open up that envelope at the end. All right, exercise 5. Find the sum of the first 6 terms of a geometric sequence if A1 is 10 and R is 5. So if I'm finding the sum, again, I need A1, which is 10. I need R and I need N. So A1, they gave me R is 10, and they also told me how many terms. We're so lucky. Okay, plug that into the series formula and find out the sum. Okay. When you have that all in your calculator, click enter, and you'll get this number. It looks like a binary number here, but it is S of 6 equals 1,111,110. Okay. Think about it. These numbers can be really big, especially if they're positive, only because they are growing by a common ratio. You're multiplying. So these numbers are going to be big. All right, and then number 6 here, the last one we're going to do. Find the sum of the first 5 terms of a geometric sequence whose first term is 2 and fifth term is 162. So A1 is 2. The first term is 2. We know we're trying to find 5 terms, but we don't know what the ratio is. Okay. So if we don't know what the ratio is, we're going to use our sequence formula. AN is equal to A1 times R to the N minus 1 in order to find out what that R is. Okay. So we know the fifth term is 162. We know A5 is equal to 162. We're going to plug that in. So 162 is equal to 2 times R to the N, which was 5, minus 1. First step, just like before, let's divide by 2. And 162 divided by 2 is 81, equals R to the 5 minus 1, which is 4. If we have something being raised to the 4th power, to undo that, we're going to take the 4th root. In your calculator, you hit math number 5. And in that little root spot, you're going to click 4. And then underneath the radical, you'll put 81. Click enter. You'll get 3. So R is equal to 3. And now that we have all of our information, let's calculate that sum for this problem. So the sum of the first 5 terms is equal to A1, which is 2, minus 2, times 3 to the 5th over 1 minus 3. Alpha y equals, boom, 2 minus 2 times 3 to the 5th, oop, not the 55th, over 1 minus 3. Click enter. You should get 242. All right. Does anybody have any questions?